Hey, y'all, it's Dr. Know-It-All. Today I'm coming to you from Muskegon, Michigan, where I am here for the Tesla takeover that Kelly Sloan and Tesla Owners Michigan has set up for this weekend. So if you're around, you should definitely come say hi this weekend. I'll be around. In the meantime, they put me up in a lovely place. Very wooded. Behind me right there is Lake Michigan, but there is very wooded dunes in between us. So it's really lovely. So I figured I'd go ahead and film this outside today because it's quite beautiful. I want to talk, however, about Andre Karpathy and about Software 3.0. So this is just a little picture of him. This is a video. These are screen grabs from a video that he did at Y Combinator School, AI startup school here. And it's really, really interesting stuff. I will leave a link to the video in the description. I don't want to take away, steal his thunder by taking pieces of the video. So I'm just going to do some screen grabs, but I highly recommend it. It's about 40 minutes long. So it doesn't take too long to listen to, and nothing is too highly technical. So you can listen to it while you're at the gym or driving or something like that. So easy peasy. I highly recommend it. So definitely go ahead and watch that. I will leave a link. Anyway, with that being said, I'm going to dial things back quite a ways. I trying to remember maybe 2019, maybe 2020, when Andre Karpathy published this little image that has since been very, very instrumental for people understanding the difference between software 1.0 and 2.0. He was talking specifically about Tesla's full self-driving. Sorry, this isn't the greatest picture. Clearly, this was done at a conference, and you're seeing someone's head in the way. But anyway, you get the idea here. You've got software 1.0, which is traditional software. It's the stuff that you think about when you think about traditional software. It's coding, it's Python, it's C++, it's C, it's assembler, whatever it is. You as a human being tell the computer what to do, and it does it exactly. And if you make a mistake, it does that exact mistake over and over again. Software 2.0 is neural network based. In other words, it's the stuff that large language models are built out of. It's just a bunch of numbers in a giant spreadsheet, more or less, tensors if you want to be specific about it. But basically doing this, you're trading off telling the computer exactly what to do. That's software 1.0, where you're just like, if this, then do this, right? If this happens, then do this. And then, of course, you can add to that looping. Looping and branching is the basis of software 1.0. Software 2.0 is much more based upon these neural network models. In other words, you give them numbers, and what you're trading is human knowledge, where I go like, okay, I understand how to do problem X, Y, or Z, and I'm going to tell that to the computer. What you're trading instead is you're saying like, here's a bunch of numbers and here's a bunch of data. I'm going to give you this data and you're going to figure it out yourself. That is software 2.0. And of course, that is a huge change from software 1.0. Things are very, very radically different now than they were even 5 or 6 years ago, because we have large language models. We have the earliest of robots that are coming out into the world, physical robots that are happening. We've got full self-driving. Tesla's full self-driving has been pretty much eaten by software 2.0 code at this point. So, things have changed quite a bit since this original slide. So I found that really fascinating, because if we compare that to now his new slide, which is that we also have a software 3.0. So we've got the original stack of software, which is human coded. A human being says, do this, if this, then do that, that kind of a thing, loop these kind of things. You've got software 2.0, which is neural network models that are working for you. It's a very, very different paradigm. You're trading off human knowledge for human data, and the data is being fed to these models, and these models are learning on their own. Software 3.0, which he is noting here, is kind of growing also, right? So we've got 1.0, 2.0 has eaten a lot of software 1.0's, lunch. And then we've got software 3.0 that's coming up upon that. What does he mean by software 3.0? He means prompting. He means basically programming in English. He created a post back, I think it was 2.5 years ago, maybe January of 2023, where he said that the new coding language is English. And he's very much right about that, and has been proven even more right. And that is software 3.0 here. And that has a lot of ramifications that I want to talk about today. And it also brings up a really, really fascinating analogy to compute of the 1960s. This is something Andre Karpathy pointed out. And that analogy is to mainframe computers with timeshare using a command line interface, a text-based interface, which is kind of how we interact with large language models now. You've got these gigantic entities, right? These big server farms that you attach to with a thin client, which is basically just a web browser or something like that. You then ask a question of these large language models. They reply, they send you back something time shared out across, millions of requests at the same time. And you get your request back, and that request is in the form of text, generally speaking. Now, obviously, there's diffusion models and stuff, and so you can get pictures and things like that out of it too. But the primary interface is a text-based interface And of course, the analogous change that happened, say, 10 years after the late 1960s, in the early 1980s, was that we went from a primarily text-based interface, which I grew up with. That was what was available at the time, both from mainframes and also from early personal computers like Apple IIs and TRS-80s and things like that. They used a command line interface, command line programming, all of that kind of stuff. It switched to a graphical user interface, famously with the Macintosh, although that wasn't the first. It was the first very popular computer that had a graphical user interface, and that really changed the game. And that's the way we operate now. In fact, I'm sitting here looking at pictures on my screen, looking at video of myself. When I get done with this, when I edit it, I will be editing it in a more or less visual interface. I won't be coding in at time, 13.02 and 57 frames or something like that. Do this, right? That would be very, very cumbersome. I'm going to be using a graphical interface to edit this video, a graphical interface to post it onto the web, on YouTube and X, etc. And all of that kind of stuff is very, very different than the old days of command line interfaces. And yet, if you think about the way that we interact with large language models right now, the large language model interaction is primarily text-based, and humans, it requires a lot of effort. This is, again, something that Andrej Karpathy talked about in his presentation. It requires a lot of effort on the part of humans to read and understand text. We're much better at visual and auditory cues. We're much better at taking in the world. I can look around behind me. I can see the beautiful world behind me. If a deer happened to walk behind me, I'd be able to notice that very, very rapidly, right? We're extremely attuned to visual information like that. We're also very attuned to auditory information. And so the problem with this text-based interface, both back in the 1960s with software 1.0, but now in the 2020s with software 3.0, is that it's just not very human-centric. It's not very useful for humans. It's complicated, it's awkward, and of course, people who have learned how to use it effectively have a high demand because they're able to more or less translate between this text-based interface and what we really want to think about in our brains. And this takes me to another slide from Andrej's talk where he talks about large language models having the properties of operating systems. And Sam Altman has recently talked about how young kids, teenagers, think about large language models as OSs. They think about it as the equivalent of Windows or Mac or Linux or something. It's an operating system that they use. It's not the way I think about large language models. I'm old, so I tend to think about it a little bit more as a conversational, companion or something like that, or a way of searching things out and doing research and stuff, but not as an operating system. But both Andrej Karpathy and also Sam Altman talk about how large language models have properties of operating systems. They're increasingly complex software ecosystems, not simply commodities like electricity. He also analogized it to electricity. Large language models are software. They're trivial to copy and paste, manipulate, change, distribute, open source, steal. They're not physical infrastructure, which is a very important point, as opposed to electricity. They also have the same amount of switching friction due to different features, performance, style, capabilities, etc. per domain. So in other words, if you want to go from Windows to Mac, you have to have a relearning process. If you want to go between ChatGPT and Claude, there is some relearning process, although honestly, there there's a lot of similarities. There's more similarities in these LLMs than there are in operating systems at this point. And then last but not least, he's got the space that you interact with this in. The system user prompt space is approximately equal to the kernel user memory space of traditional computing. And again, that is very command line centric. It's very text centric. And so software 3.0 is very text based. It's a thing where you talk to these LLMs. You can do that in a standard chat window. You can do it inside Cursor or Replit or something where the AI can go out and it can look around at your code and it can help to rewrite it and it can respond and it can give you suggestions, or it can actually make Git commits and all of that kind of stuff. And by the way, a quick little side thing here, he posted this cool picture of a map of GitHub, which is you've got, all of these sort of areas where things are clustered in terms of what GitHub repositories there are. So really, really fascinating image that's here, and it's just a little side thing. But anyway, the import of this is that if you've got a very highly autonomous agentic AI that's able to do things, it can actually make commits to GitHub or other repositories to actually generate this code and version it and do error correction and all of that kind of stuff with you, which is very, very cool. And speaking of that, Andre showed this LLM OS operating system, this approximately operating system that he's talking about, a schematic diagram. So you can see the LLM is in the middle of it, sort of like a CPU. Then you've got RAM, which is the context window, which is how you talk to the thing. And then outside of it, on the right-hand side, you've got browsers and other LLMs that can actually talk to those. On the left-hand side, you've got tools. You've got things like classical, a calculator, Python, stuff like that, and terminal, all of those kind of things, and a file system that it can communicate. That's much more software 1.0 type of infrastructure and stuff. And then it's got access to peripherals and devices like video and audio and stuff. So it can IO, that kind of a thing. So it is growing away from being text-based only, but it is still primarily text-based. Feels very much, when you think about it, like the 1960s of operating systems. And of course, Andre gave us this really cool slide of, operating systems in the 1950s through 1970s. I love this Wang Basic 3300 where people are literally connected to it on the floor, sitting around typing. You see people in ties and nice dresses and stuff sitting around this machine. Clearly, that was a marketing image, not real, because I'm sure people would normally sit at desks. But still, it's a really, really fascinating kind of look into how things used to be. And that's more or less what we're still doing now, right? We've got our laptops instead of these sort of teletype machines. And obviously, we are connected through the internet to these server clusters. But the analogy holds pretty strongly here with LLMs. You've got essentially the replacement of this Wang 3300 basic thing, and you've got the replacement of these teletype machines with much broader internet. And of course, many, many more people can use this at the same time than used to be able to, but it's still very much that same sort of paradigm, and it's still very much text-based. And then we get to this interesting slide where Andre argues that what we're looking at is a workflow of partially autonomous UI UX. So in other words, the AI is responsible for doing some of the generation. It's responsible for creating some of the stuff. Then a human comes in with the help of AI, and you can see how these things are kind of like, they co-evolve with each other. But let's just divide it up for a second. So let's say the AI generates an answer. The human then validates that answer or verifies it, and then makes further suggestions to the AI. The AI then generates another go round at it. The human then evaluates it, et cetera, et cetera. But you could also have the AI ask questions of the human and say, like, if you ask ChatGPT to do deep research, it will ask you questions before it starts. It's like, hey, did you mean this or did you want that? So you can have the human being generating some of the information and then the AI doing some of the validation, verification, et cetera. So these things can blend into each other. But what Andre is saying here is that this is the best way forward right now. Eventually, we might have fully autonomous AI agents that can do everything on their own, but that is not the case now, and very likely will not be the case for the near future for complicated tasks. For easy things, then sure. But for more complicated stuff, it's going to be a while before we get to fully autonomous AI. And in the meantime, we've got this human AI kind of co-evolution to come up with solutions together. So that's a nutshell of part of Andre's presentation. What I want to talk about at the end now is, what would a large language model GUI look like? What would a graphical user interface for a large language model look like? So we know that text sucks as an interface, right? That's just a note that I wrote. We know this because terminals are not the primary way that we use computers right now. It's also not the way we interact with each other. We don't sit there and like type information to each other, although we do tend to text message each other. But even with that, we tend to send GIFs and we send memes and things like that. So we send more information than just text. Text, it's fine. I mean, it's great. If you can put things into a book, you can preserve it for future generations to have, but it's not as easily interactable as other modalities for humans. So let's take that as kind of a given that text, it's not the greatest interface. There are better ways to do it. We went from the terminal interface to a Mac interface in the early 80s, and that changed things, right? Then Windows caught up, and then of course Linux caught up, and there still are terminal things, and I'm going to talk about coding more in just a second. But our primary way of interfacing with computers now is through graphical user interfaces, not through command lines. However, our primary way of interacting with large language models still is very much text-based. And returning back to coding, an interesting aspect of coding is that it's kind of stuck in that 1960s paradigm. Now, obviously, there are SDKs, there are software development kits, there are things that are available to make it easier, but coding is still very, very much text-based. And it's something, I don't know, I guess I'm just sort of used to it and don't think about it that much, but Andre's talk got me it sort of jogged my mind and made me go like, wow, why are we interfacing with coding like this? Because text is very complicated. It's hard for human beings to interface with. And when we have to look at that code and we have to ingest all of that code, it takes years to become proficient at writing and understanding and being able to rewrite code. And a lot of that is because the interface is just not ideally suited for humans. It's very, very well suited for computers. Computers are great because you can type things in as long as the syntax is good. Everything is cool. And that's one of the advantages of software 3.0, of course, is that if you're using human language to interface with the computer, the syntax doesn't have to be quite as exact. But as I've pointed out in another video that I will leave a link to at the end of this video, that when you get to actually programming in English, you actually have to be very, very exacting. And so the syntax actually becomes really important and the semantics become really important in the way that you interface with the computer, even through prompting. So there's a kind of convergence between computer syntax and human syntax when you deal with a computer in that sort of prompting language. But the interesting part about this all is that still and all, computer programming is very awkward for humans because it's just not the best way for us to interface with something. Text-based stuff that just sits there on a page and that you have to read and ingest and kind of grok it, that's very, very difficult for humans. If we're rethinking the way UIs and UXs work, why not rethink the way programming works? There's got to be a better way for programming to work than what we're doing right now. Even if it is just English prompting of a large language model, there still have to be better ways than textually doing that. And so this last section is clearly not me coming up with answers because this is a very complicated thing and I don't know the answer, but I think it's valid to ask these questions and to start thinking about the answers. And if anybody wants to think about the answers with me, let me know in the comments. That would be awesome. Anyway, so as I've highlighted here, there must be a more imagistic, humane interface way to interact with large language models. The Humane Interface, of course, being Jeff Raskin's very, very famous book where he talked about an interface that was better for humans. This was an advocacy for the things like the graphical user interface that we're all now very familiar with and seems in hindsight obvious, but he was making an argument for it. He was one of the people who designed the graphical user interface for the Macintosh computer, and therefore he thought a lot about interfaces. And what I'm saying here is that analogously, we've got a kind of inhumane large language model interface. It's designed more for the large language model's benefit than for ours. Typing in text is not ideal for a human being to interface. It's slow. It takes us time to think about how we want to say what we want to say. It just at a very basic level, at least a voice interface would be much more natural with humans. And yes, those things are beginning to exist, but they're still kind of awkward and clunky and they don't work as well as they could. And even that has downsides that something that's even more imagistic or something would be able to overcome, or some sort of shared interface that uses all of them. The common graphical user interface that we have now on our computers involves both, kind of command line stuff where you type in things in text, and it also has a lot of stuff that sort of correlates to the physical world, like a desktop and folders and stuff like that, that people don't even think about anymore. But of course, that all had to be thought out at one point. And then in addition to that, we have images, we have audio, we have all this multimodal stuff so that it can trigger different parts of our brain that can work as rapidly as possible under different circumstances. So that's the kind of thing that we have in our computers right now, but they're really, really lacking for large language models. And they're also really lacking in our coding environments too. And that was an interesting revelation as I thought about this talk from Andre. So if we're moving to software 3.0 and we have time to reimagine the user interface with software 3.0 with prompting and stuff, what does that interface look like? I will say I think it should be fully multimodal. It should have images, video, audio, and text. Of course, it needs text sometimes as well. And in the future, I could see having a neural implant in your brain so it could actually read your thoughts, which would make things go even faster. Because one of the problems with these interfaces is how many bits of information can you take in as quickly as possible and reproduce as quickly as possible? I can talk faster than I can type, which means that the amount of bits of information I can say to a computer is much faster than the amount I can type because I can talk faster than I can type. I can also receive information much more quickly. Again, I can look at an image very quickly and take in a whole bunch of information. Whereas if I had to read a text description, it might be a paragraph or something, and that would take me time and thought and all of that kind of stuff. Jan LeCun has famously talked about how a 4-year-old child has ingested about the same number of bits of information just from interacting with the real world as all of human knowledge put together. And I don't know if that's an exactly correct figure from him, but it's a really profound thought if you think about that. The natural world is giving you as much information by the time you're 4 as all of human knowledge, if you could ingest all of human knowledge together, the same number of bits. That means that we have a huge amount of information coming in, and we're really good at ingesting it. So how do we actually move from this really primitive, very slow, very cumbersome, not very natural interface of text into something that is fully multimodal from the get-go, that has audio, has video, has images, has text, is much more like interacting with another human being rather than interacting with something that's, awkwardly on a computer. To finish up, I'll throw out another analogy. I was talking to Ben, my co-founder of Artomatic, yesterday. In fact, we were talking about this, and he was making a pitch for us becoming more of a hybrid work environment. And I very much agreed with that because the interface, even in Zoom or Slack huddles and things like that, which are great, they're just not as effective as being in person with another person, at least some of the time. And the analogous way of thinking about this is that large language model interfaces and computer interfaces in general are okay, but they're just not perfect. They could be better. And why not, if we've got this software 3.0 coming online, why not think about how to make a better interface at the same time? So Andre's talk obviously got me thinking in really, really interesting ways. I highly recommend watching the entire thing because it goes into a lot of other stuff besides what I was talking about. And of course, please let me know what you think about all of this, and any suggestions you have, let me know in the comments while you're down there. If you don't mind liking the video, it really, really helps out the channel. Thank you. And if you enjoy this kind of content, please consider subscribing for more of this, and I will see you in the next video. Bye-bye.